Bismillah wa salatu ala Rasulullah. In the previous lecture, we went back to moment and took it in explained it in a little bit of details. But today we're gonna go back to video number 3, structural analysis number 3, and we'll continue with the classification of structures and calculating the reactions and the values of those reactions. Of course, you'll find in the description notes pages, and in lecture number 3, in structural analysis video and structural analysis number 3, we have corrected type errors in page number 12. So there is if R equal 3n and if R bigger than or larger than 3n, or if R less than 3n. So we have it's 3n, it's not plus c, and you can go back to video number 3. Also with the teacher we have added some stuff about special cases. We didn't go there in this in the previous lecture, and we will not go there in this lecture. You can Google it, or you can go to ChatGPT or whatever and ask about the special cases and the classification of structures. So we're gonna start with we're gonna explain a few examples today. Hope will that be enough for this chapter. So let's start. Here I got 3 forces here. Well, this is a distributed force. We have to make it concentrated force. But first we have to calculate the reactions of this support and this support. So what are we having? You go back to the pages and the notes that you'll find in the structure. We have a roller support in the middle. It's a roller support. You can find it in page 6, and a fixed support in the beginning. This is a fixed support, and this is a roller support. Okay, so later in page 7, okay, so what we said, we're having a roller support and a fixed hinged weight, a fixed support. So the fixed support in page 7, the fixed support, which is this one, has 3 actions. One in the y-axis and one in the r-axis, and one is a moment reaction. Okay, so what we have here? Here we have 3 reactions. Let's draw them. So we got here, we got one reaction here in the, we got one reaction in the x-axis here, and we got one reaction in the y-axis here, and we got one reaction, one moment reaction like this. So we got 3 reactions here. And for the roller support, you go into page 9. It's written in Arabic, but you can understand it from the drawing, the arrows. So in the arrow, there is only, in the roller support, there is one reaction, only in the y-axis. So in case of this in the case of this support here, wait, I can't see the cursor. Okay, this support has only one reaction in this direction. So what I have here, the reactions are equal to how many unknown reactions I have are equal to, I don't know, 4, right? Wait, how many reactions do I have? Wait, wait a second. So wait, I have 4 reactions. Excuse me for a little bit. Bear with me, please. Okay, so what I have here is R equal 4 because I have 4 unknown reactions. I have 4 reactions, and the 4 is bigger than the 3 in 1 multiplied by 1 because it's one joint. There are no joints here. It's only one piece. This is one piece. Structure here is one piece, or the beam or whatever is one piece. There is no joints. There is no joints to divide the structure into 2. So it's one. So it's bigger. 4 is bigger than 3. So it's the structure is statically indeterminate. The structure is statically indeterminate. So the structure of is statically indeterminate. So in this case, we can't find the unknown reactions, the value of the unknown reactions, because we only got 3 equations, which is, as we explained before, we got the sigma fx equals 0 and the sigma fy equals 0 and the sigma moment equals 0. So I got only 3 equations to solve. So in order to solve, to find the value of any reactions, there got to be the R must equal the 3n. Okay, so in this case the structure is statically indeterminate and we can't find it through or we can't find it through these 3 equations. Probably there is a way that's harder or whatever. So we'll go the same for example, but here we got a joint in the middle. So this is 1 and this is 1. So what we have here is we can say is that I got um, wait. Wait, what do we have in here exactly? Okay. So in the joint, in the joint, the joint adds. Okay. So here the reactions is gonna be the same for as before. So we're gonna reaction this way and this way on this and this the moment reaction on this support, and in this support we're gonna have a reaction this way, but we also have two unknown uh, two unknown uh, uh, two unknown reactions because of the joint. So this joint adds to this joint. At this joint we have two reactions. Okay, two unknown reactions. So how many reactions I have? Six. And six is and we have how many? Three, and we have two parts now, two parts of the structure. So it's multiplied by two. So six is equal. So this is structure is statically determinant, and we can solve it on two parts. First, we have to divide the drawing into two parts. So in part one, we're gonna take this side of the structure, this side of the structure. Okay, so in this side of the structure alone, we're gonna take this part alone. It's gonna be we're gonna draw it, and we're gonna calculate the values of the unknown uh, values of the reactions. So what we're gonna do is we're gonna come here and go here, and we're gonna draw this structure and put the forces in its place. So this is 100 Newton, and this force here we got the joint, and in this place the reaction is going to be this way, and this reaction is going to be this way. So, because the reactions must cancel each other, so that the structure is statically determinate. Okay, and this force we're gonna analyze it. This force that comes like this force, we're gonna analyze it, and it's gonna be in these directions. It's gonna be in these directions. So um, a force is gonna be uh, I don't know, this direction, and a force is gonna be this direction. So let's analyze it. The x equal I don't know why am I not having, there must be, yeah, I forgot the degree, the angle degree. So here we got, let me go back and take the red color. Here in the equation, in the question, there must be an angle degree. So this angle degree is 60 degrees. So going back to our drawing, what we're going to do is we're going to analyze it. So we're going to say x equal 200, which is the force value. The force is 200 Newton, as is shown in the question. So 200 cosine 60, and then we got the y equal 200 cosine 60. Okay, am I right? Wait, and we got also we also got, yeah, almost forgot. Let me clear this out of the way. And I also got the reaction of the support over here, which is, I don't know, we'll call it by, and this is, we'll call it cy, and this we'll call it cx, which is, these are unknowns. And we got the x. I'm constantly checking in the papers I have so that I don't make a mistake that is gonna I don't know. So that I don't make a mistake, because this is a responsibility of mine to deliver correctly. So what I have is, okay, yeah. So in the x direction, yes, it's 200 cosine 60. So going to my calculator, 200 cosine 60 is equal to 100. So this, where's the cursor? It's going to be a long lecture, huh? So this is the x-axis. So this is going to be 100 Newton. And we have 200 sine 60, which is going to equal 173.2. So this here in the y-axis is going to be 173.2. Why? Because here the y equals 200. Remember, we're building up from structural analysis number 1. So we have already discussed how to analyze the forces. So here in the previous lectures, so here the y is this, and the x is this, and this is the law of it. So we're gonna start solving this part of the equation, or this part of the structure. We're gonna start with sigma f x equal 0, and we're gonna go and find out how many x's do I have. I have cx plus, we're gonna assume that this side is positive and this side is negative. Okay, and what I have only two forces in the x-axis, which is this one and this one, right? The cx and the, so it's going to be minus, because of what we assumed, it's going to be minus 100 equal 0, which give me the cx equal 100. So this unknown we already found. We're gonna go to the sigma fy equal 0. And how many reactions do I have on the x and the y axis? I have 1, 2, 3, 4. So I have the by y, the cy. I'm gonna assume that the upper ones, the arrows that is pointed to the up are positive, and the arrows that's pointed down as negative. So what I'm going to do is cy plus by, and what I have is minus 173.2, and then minus 100 minus 100 equal 0. So what I'm going to have is cy plus by sorry, equal minus 100, plus 100 because we've transferred it to the other side of the equation, plus 173.2, which is going to be cy plus by equal 273.2. So we got this, but here, because we have two unknowns, we haven't really gotten into any, we haven't find out, and we can't, so far we can't find these two unknowns precise values, but this will come handy in checking out what we gonna get from the moment. So we're gonna remove this, and we're gonna go to the moment. So here I have, let me give this names. Here I have this this part A, and this part C, and this part B. Okay, I'm going to solve the moments in any parts I want. So I'm going to start with A. No, I can't start with A. I can't start with this one. It's either I start with the B, or I'm going to start with the B. Okay, so because we're having this part here. So I'm going to take moment at B. I can start with C, I guess, but I'm going to start with B. So I'm going to take the moment at point B, and I'm going to assume this side, this clockwise is positive. I'm going to say equal 0, and I'm going to start solving. Of course, here I'm going to draw lines. So okay. So what do I have? What do I have? Back to this. What do I have? I have 100. Okay. So here the distances are going to be, of course, valuable. We can't solve without the distances. So I'm going to say here is 2 meters, and here is 2 meters. Okay, the distance. So what I have the by already equal to 0. Why? Because it goes through the B. Okay, so you know what? If I took the moment, okay, we're gonna go back. We're gonna take it through the C again, but here the by equal to 0. So um, as you know from the moment, this goes um, through the point B. So which means that here we don't have a perpendicular um, distance to the point. It goes through, actually right through it. So the by here is going to be equal 0, so we're not going to write it down. But we're going to have the 100, and the 100 is going with the clockwise. So if we suppose this is the clockwise, the 100 is with the clockwise, so it's going to be positive, and we're going to multiply it by 2, so it's going to be 200, right? So we're having 100 multiplied by 2, 100 multiplied by 2, positive, plus. Okay, I'm gonna open parentheses. I'm gonna go to the other side of the equation. Okay, and the other side of the point, sorry, not the equation, no. The other part of the of the point B, which is this, we got the Cx, which goes right through the By, and we got the 100, which its line of action extends from here, so it goes through the point B. So this and this will equal 0. So what I actually have is the Cy and the 173. So I got 173.2 multiplied by 2, and I got the Cy multiplied by 2, and the 173 is going to be minus because it's in the opposite direction of the clockwise. If we take this point as with the clockwise, if we assumed it's positive with the clockwise, so it's going to be against the clockwise, or the positive direction of the clockwise. So it's going to be, let's see, here, this is minus 173.2 multiplied by 2, and we got a positive, because it's with the clockwise, Cy multiplied by 2, which is going to give us equal to 200 positive, or sorry, minus, where is the cursor, minus 173 multiplied by 2 minus 346.4 plus 2Cy equal 0. So we're gonna take this 2Cy and move it to the other direction. So it's gonna be 200 minus 346.4, which is gonna give us minus 146.4. So it's gonna be minus 146.4 equal minus 2Cy, and this minus, we're gonna divide both over both sides over 2, over minus 2, so this will go, and we're gonna divide it by minus 2. It's gonna give us 73.2. So here we calculated Cy is equal to 73.2. So if we took this, we can stop here. We could take this, the Cy, okay? We could take this, the Cy, and take its value and put it over this Cy, and move it to the other direction. It's going to be minus 73.2, which means that the By is equal 200, and that will solve all the, which means that the By, we have already find the, the Cx, the Cy, the By. We've already found all the unknowns in this part, but we're gonna take a preventive measure and calculate the moment from this side to just know, to be sure that we haven't made any mistake regarding our calculations, just to be sure. So we said from this moment that the Cy is equal to 73. So I'm gonna erase this steps here that led to this. All this, erase it, and I'm gonna erase this B. Okay, go back to my color and take it from point C. So in point C, I got Cx and Cy. I got Cx and Cy going through the point C, which means they are equal to 0. So I'm not gonna, and I got the 173.2 equal to 0 also because it goes on the point. It goes on the point, through the point, even if you don't see it, because the drawing is not accurate very much. It's not very accurate, but it goes through it. Like if you see it over here, it goes through the joint. So the 173 is equal to 0. So how many am I left with? I'm left with the by, the 100. Also, wait, also the 100 goes through this. So I'm left with the by and the 100. I'm left with the by and the 100. This all goes through the point, so these four forces equal to 0. So what I'm actually left is by and is against the clock direction. So this is the clock direction that I assumed equal positive. So it's against it, or it's in the opposite direction of it. So it's going to be minus by multiplied by 2. So I have here minus 2 by. Not going to bother doing all the steps. I'm gonna have shortcuts this time. And what I have is this 100 with the clockwise. This 100. This force is with the clockwise as we assumed. So it's a positive 400 and multiplied by 2 and 2. So it's going to be plus 2. So it's going to be multiplied by 4 meters, which is the distance as we discussed in the moment video that we did. So 100 multiplied by 4 is 400. So it's going to be plus 400. Plus 400 plus 400 equal 0. This will go here. It's going to be minus 2 by equal minus 400 over minus 2, so that this 2 goes. So it's going to be by, it's going to be by equal to 100. So my calculations are very correct, and I have, if we add this to this, it's going to be, if we add the by to the cy, it's going to give me 270. It's going to, okay, this is 273. So it's going to be no. If we add, this is correct. If we add the 200 and the 73.2, it's going to give us, just as we find out before, 273.2. So it's correct. So I've already found the solution of this part. I'm going to go to this part and do the exact same steps. If you want to stop here and try to do the steps on part 2 and make sure that you got them right. So I'm going to erase everything except what I have found earlier, because it's going to become handy on these parts. Wait. course, I took this part because it's much easier. Okay, why? Because I have, suppose I started here. Um, I'm gonna have more because I have three. Look, if I started, wait, let me first erase this. Picking the first part is essential. Okay, the why. I'm gonna give you why. I'm gonna tell you why. First, if I was to start over this part, I'm gonna have 5 unknowns. This one, this one, this one, this one, and this one. 5 unknown reactions. And it's gonna be nearly impossible to solve with these 3 equations of stability. Okay? So I needed to start uh, with the other part first because I'm only having in this part before I solved it I only had 3 unknowns, which is this and this. 3 unknowns, which goes exactly. Now I got this one, which is the cx, and I got the cy, so I'm only left with 3 unknowns over this part. So I'm going to start and draw. Okay, I'm going to start over here. I'm going to start over here, and I'm going to draw the other part, just like this. Okay, I have this part, and I have okay. So in this time, the reaction of this point, which is C, is going to be this way and this way because it has to be, or what did we have in the first? It has to be the other direction. We're going to find that, no, it's going to be this way and this way and this way. Why? The why is because it has to be over. So we choose this way because we have that direction here. Did we start from here? We have one over here. It's going to be one over here, and we have a moment. So it has to go the other way around. Okay. So again, unlike what we assumed before, it's going to be the other way around. So it's going to cancel. We're going to see now. How's it going to cancel this? We're going to cancel this. Okay, this. We're going to cancel this. No, this one. Okay, let's start. What are we having? We have a moment already. Okay, and what do we have? We have this distributed force. We're going to multiply it with the 50 by 4. It's going to give me 200. And this is going to be, and the distance here, the 4, is going to be divided by 2 to give me a concentrated force. So here in the middle, we're going to have a concentrated force, which is 50 multiplied by 4, which is 200 Newton all this time. And this distance is going to be 2, and this distance is going to be 2 meters because the 4 was divided by 2. And we got 3 reactions over here. So I got one that goes up, one that goes in the other direction, and one goes as we assumed it, the moment. Okay, or wait. The moment. in the hinged support. Okay, I'm going to assume it's with the positive direction. Okay, so it's going to be in this direction, in the positive direction. Okay, then moment. So what I have AX, AY, and MA. So I'm going to start with the FX, and here I have the CX, which is 100, very important. The BY is not important here. The BY is not important. The BY is not important. Okay? What I need is, and this is not important, what I need is the CX and the CY. So what I found out from the part 1 is that the CX, this one is 100, and this one is 73.2. So I can go ahead and erase this, and start over. Okay, so wait. Assuming must be on the, I don't know about the assuming. I don't know if it's going to change anything, but I'm going to assume it as written in my, I'm going to assume the moment in this direction, so it cancels the moment on the other direction. So I'm going to assume it this way. So it's canceling what I'm going to assume the moment. So this is MA, and this is AY, and this is AX. And sorry, this one is not this. I'm going to assume it's the other direction, so it cancels this direction. So I got here one goes up, I must get one goes down over here. Unlike what we took in part 1, it has to be of course I don't have enough space here, but it has to be on the other direction of what you assumed in part 1. Okay, let's start. And the 73, okay, let's erase this. This 73.2 is going to be here. I'm going to start with, sorry, I'm going to start with sigma fx equal 0. I'm going to start. Okay, I'm going to assume the up positive, the down minus. Okay, Okay, what do I have? I have AY plus, sorry, minus 200 minus 73 minus 73.2 equal 0. So I'm going to have AY equal to, which gives us, this is going to give us AY equal 200, because it's going to be positive on the other side. It's going to equal 273.2. Okay? Okay? Okay. What else? This is one. I'm going to say sigma Fy equals 0, and I'm going to assume this way is positive and this way is minus. So I'm going to go with my assumptions. I have Ax positive, then I have and I have minus 100. I only have this two reactions on this side, so I'm going to go minus over 100. It's going to give me Ax equal 100. So what I'm left with is only one unknown, which is the MA. So I'm going to take the moment at, I don't know, I'm going to take it at MA. Do you want me to take it at, I don't know. Okay, let's have it at MA. I'm going to take it this way is positive. I'm going to say, so it's going to be equal 0, of course. So it's going to be, okay. So it's going to be, okay, let's say the X, the AY, the AX, all going through the MA point. Okay, so it's irrelevant, and I have 200. I assumed it's positive here, so it's gonna have, wait, this is actually confusing to me. So 200 over 2 going with the clockwise, so this way, and the 100 goes, so I got 200 plus 2 clockwise, and I have plus 73.2 also clockwise multiplied by 2. So do I have any other directions? I don't, right? It all goes through the point, which is MA, the point A. It all goes through the point A. Note that I have assumed it clockwise positive. So 200 is going to be 400. Okay, so this needs a calculator. It's going to be 200, right, parentheses 200 by 2 plus 73.2 multiplied by 4, not 2. Yeah, let me, this is going to be 4. Okay, divided by 4 gives me 692. The MA gives me the MA equal 692.8. But just to make sure, I'm going to take the moments from the C direction. I don't know if I assumed that if I assumed it with the clockwise positive, then my drawing would be incorrect because I must go the other way. But let me go and see from the C moment. I'll take the moment from the C. Take the moment from the C with the clockwise from point C, clockwise positive. So I got the 73 and the 100 goes through the points. It's not going to be valid. And I got the AY as well. The AX, sorry, the AX goes through the point. So it's going to be 0. So I'm left with what? 200 and AY and MA. And this is going to be tricky a little bit, but we're going to see. The 200 is going to be minus 200 multiplied by 2 and plus the AY is going to be positive, and the AY we already calculated is 273, so it's going to be 273.2 multiplied by 4. I don't think there is another. I don't think this is necessary anymore, but let me check with you. Multiplied by 4. Okay, positive. And I'm going to have the MA in the other directions. It's going to be plus the MA, but the MA is going on, so it's going to be minus the MA. And I have already calculated the MA, so it's going to be, otherwise I'm not going to be able to, if I have to, I don't know. Okay, minus the MA. Minus the MA. So what I'm having here is I'm having, okay, equal 0. So I'm going to take this here. It's going to be MA equal the rest minus 200 multiplied by 2 plus 273.2 multiplied by 4 equal to 692.8. So the MA, which gave me the same results, the MA equal 692.8. So it gave me the same results. Let me check from my 692.8 Newton meter. So this, we solved this Odely-Hart equation. We're going to go to the next concepts. So here I have how many reactions? I have, I'm going to draw it. Here I have 3 unknown reactions. Three unknown reactions. reactions. Take it like this. So 3 unknown reactions. So I got 3 equal, and I got one support, one structure. So it's going to be 3 multiplied by 1. So 3 equals 3. So statically determinant. So what am I going to need? The only difference here is I got the 10. This is what's different. So if you go with me to page, if you go with me to page 11, you're gonna find out the equivalent system of distributed loads. So we've already covered the first situation. We got the other situation, which is a triangle. Okay, so it's distributed in a shape of a triangle. We're gonna have to find the um, uh, okay, so you're gonna have to find the area of the triangle to find the force value, and we're gonna have to distribute it over distance over third, and then the rest is the 2/3. So what we have here is okay. Okay. So what do we got? We got the height is 10 and the width is 12. So we're gonna draw it. We're gonna draw it over here. So we're gonna say this. We got third of the 12. So I got 1/3 multiplied by 12 gives me 4. So I got 4. Wait, where's the cursor? I got a 4 over here, and the rest is 4 out of 12 reminds the remaining is 8, and I got here okay, so I got 4, and this as in the force, it's going to be half multiplied by 10 multiplied by 12. So it's going to be half multiplied by 10 multiplied by 12. It's going to be 60. So this force is going to be, this force is going to be 60, and I got no shit. Okay, can I go back? Control Z. Okay, I get it. The thing. Okay. So get a line like this, and I got one force over here, one force over here. I got this force, this moment. So this is gonna be MA, this is gonna be AY, this is gonna be AX. So what am I having? Okay, we're gonna start solving now. So we're gonna say sigma fx equals 0, and I'm gonna assume sigma fx, this is fx. Okay, I'm gonna assume this is positive, and this is negative. So I'm gonna go ax. I only have one in that direction, positive, equal 0. So this is my solution for this one. Ax equals 0. I got no other. And this makes sense because I got no other force in the x direction. So it must equal 0 because it has to cancel each other. It's determined. So Ax is equal to 0. So what I have next is, okay, what I have next is sigma Fy equals 0. I'm going to assume the upper positive, the down negative. I'm going to go, I got Ay positive, and I got minus 60 equals 0, which gives me Ay equal 60. So I got the Ay, and I'm left with the moment. I'm going to take Ma. This is actually quite easy. I have no other way. So, okay, I'm left with the moment. So Ma equal, what do I have? Positive. Okay. I have Ax equal to 0 because it goes into, so I got 60 in 4. I got 60 plus 4 multiplied by 4, and the x is the 60 multiplied. That's the only force I have. The 60 multiplied by 4, and is it with the clockwise? Clockwise it is. So it's going to be equal to 60 multiplied by 4 equal to 240. So it's going to be equal to 240. And I got the uh, moment. I got all the three. So I'm going to move to more complicated one. So let's try and solve this one. This, of course, I got I got a mix of the two previous situations here. So what I'm going to have to do is I'm going to have to divide this into, I'm going to have to go here and divide it into a triangle and a rectangle. Okay, so I'm going to have to go here, and what am I going to do is going to take the 15 minus 5 is 10. So I got a 10 over here in the triangle. So I got the triangle part, is 10, and I got the rectangular part. Rectangular part is 5. So this is actually a complicated one. So it has the same reactions, 3 and 1 joint, so it's statically determined. I can calculate it, but I'm going to have to draw the drawing. So I'm going to start with the 5. So I'm going to go here. I'm going to go here, here, here. I got 1 in the middle here, so it's going to be E12, so this is going to be 6. Okay, I got this is 6 and this is 6 here. I got the rest is 6. So and this going to be 5 over 12. 5 over 5 multiplied by 12 is going to be 60. So I got 60 over here. And I got the other one, the 10. I got the 10 multiplied by, again, the 10 is multiplied by half over width and height, which is 10 over 12. 10 over, so I got half multiplied by 10 multiplied by 12. I got 60. So I got 1 again here, 60. And the distance is going to be the same one as before. I got 1/3 multiplied by 12. So it's going to be 4. So here is going to be 4, and here is going to be 2. So I got this. Hope I got it right. This is actually a complicated one, so I'm going to go back. You'll find this example actually solved in page number 16. So yeah, yep, I got it right. Okay, let's start solving. I got to erase this, sorry. Okay, I have 1 in this direction, which is a y, and I got a x in this direction, x, and I got a moment. I have to assume it anywhere. I'm going to assume it in the positive direction. So I'm going to go okay, let me start. Okay, I'm going to go with the sigma fx equal 0. I'm going to assume this side is positive and this side is negative. I'm going to go with it and my assumptions. So I got the x positive and I got the x equal 0 because I have no other reactions in that direction or forces in the x-axis. So that's easy, and I got sigma fy equals 0. I'm going to assume the up positive, the down negative, and I'm going to go with it. So what I have here is ay positive. I have negative 60, negative 60. Remember here I don't need the distance because it's not moment, so it's going to be equal 120. So I got the AY equal 120 because minus 60 and minus 60 is minus 120. If we move it to the other side, it's going to be 120. So I got the AY equal 120. Let's go to the moment. The MA assumed it positive. This is the tricky part. The MA, I assumed it okay in this direction with the clockwise. So I got the AY and the AX going through the point. Doesn't really affect it, and I got 60 all positive. Apparently it all goes with the clockwise, so I got 60 multiplied by 4 plus, of course, parentheses, plus 60. Where is the cursor? Fucking cursor. 60 multiplied by 6. Okay, so I got 60 multiplied by 4 plus 60 multiplied by 6. It gives me 600. It gave me equals 600. Does it equal 600? It equals 600 Newton. Kilonewton per meter. Okay. Kilonewton per meter. So what I have, 120, 0. This is it. And this is our, we're gonna finish here. I hope we covered this chapter thoroughly. I have a lot of other examples, but this is it. If you understand it to here, you've done all right. So thank you very much. This is all. And thank you for bearing with me. Thank you for, please hit the subscribe and the like and make comments. And thank you very much for your support and your enthusiasm.